Which graph matches the equation y equals 1/5 times the square of x plus 2 minus 2? Our textbook refers to this form of the equation as the standard form for the equation of a parabola. Other sources refer to this as the vertex form for the equation of a parabola. Notice because the x part is being squared, the equation fits this first form with the form y equals a times the square of x minus h plus k. When we have the equation of a parabola in this form, the parabola has a vertical axis of symmetry, which means it opens up or down. If a is greater than 0, the parabola opens up. If a is less than 0, the parabola opens down. In our case, notice a is equal to 1/5, so because a is greater than 0, we know the parabola opens up and will look something like this, with a vertical axis of symmetry. In this case, this is not that helpful because notice all 8 parabolas do open up. In addition, the vertex is the point h comma k, and the equation of the axis of symmetry is x equals h. Let's determine the vertex using the given equation. Notice in our notes, inside the parentheses, we have x minus h, and for our equation, we have x plus 2. It's important to recognize here this means h is negative 2, because x plus 2 is equivalent to x minus negative 2. So h is negative 2, and therefore the x-coordinate of the vertex is negative 2. If it's helpful, we could rewrite the given equation as y equals 1/5 times the square of x minus negative 2, where again x minus negative 2 is equivalent to x plus 2. And then of course we still have minus 2. And then the value of k, because we have minus 2 on the end, is negative 2. Negative 2 is the y-coordinate of the vertex. Now we know we're looking for a parabola that opens up and has a vertex of negative 2 comma negative 2. Let's narrow down our choices. Analyzing all 8 graphs, only 2 of the parabolas have a vertex of negative 2 comma negative 2. Both are in the second row. Here's one, where the vertex is negative 2 comma negative 2. The next graph also has a vertex of negative 2 comma negative 2. And there are 2 ways we can determine which graph is correct. One way is to consider the absolute value of a. The absolute value of 1/5 is 1/5. If the absolute value of a is greater than 1, the parabola is vertically stretched, which makes the parabola more narrow. If the absolute value of a is between 0 and 1, which is our case, the graph is vertically compressed and is more wide, which means this graph here is the correct graph. Another way to verify this is correct would be to find the intercepts. Let's go ahead and determine the vertical intercept using the given equation. Recall, to determine the vertical intercept or y-intercept, we set x equal to 0 and solve for y. So now we'll substitute 0 for x in the given equation, which gives us y equals 1/5 times the square of 0 plus 2, or the square of 2, minus 2. Simplifying, we have y equals, the square of 2 is 4, 1/5 times 4 is 4/5. 4/5 minus 2, or 2 over 1, where the common denominator would be 5. Notice we have 4/5 minus 10/5, which is negative 6/5. If we want negative 1.2. I'm going to go ahead and use negative 6/5. So of these 2 graphs, notice only one of them has a vertical intercept of 0 comma negative 1.2, or 0 comma negative 6/5, which is this graph here on the right. Almost looks like the point is 0 comma negative 1, but it's a little bit lower. The exact coordinates are 0 comma negative 6/5, which indicates this is the correct graph for the given equation. I hope you found this helpful.